Hi all, welcome to Tech Forum. In this video, let us explore building Gen AI applications using various MongoDB capabilities along with other tools like Olama, Streamlit and LangChain in local system with Docker. Generative AI is transforming how we build applications, but creating AI powered applications isn't always straightforward. You need robust infrastructure for data storage, retrieval, scalability, and efficiency. And this is where MongoDB comes in. AI models are powerful, but they are only as good as the data they can access. To truly harness their potential, we need to provide them with relevant knowledge and context. And that's where MongoDB plays a critical role. How MongoDB enhances AI applications. The first one is Retrieval-Augmented Generation (RAG). MongoDB's vector search capabilities allow rapid retrieval of relevant documents, making it a perfect match for RAG systems. Building knowledge graphs supports graph-like relationships, making it perfect for building knowledge graphs. Scalability and high availability scales horizontally, ideal for AI systems handling large data sets. Deploy globally distributed databases with MongoDB Atlas for low latency performance. Security and data integrity, built-in authentication and access control. Vector search, efficient similarity search over embeddings via MongoDB Atlas vector search. MongoDB's GenAI Showcase is a collection of tools and applications designed to help developers quickly build AI-powered apps with MongoDB. You can access the GenAI Showcase from this GitHub repo, MongoDB Developer GenAI Showcase. This has a lot of apps and tools. You can go through this for more details. These examples provide a strong foundation for building your own AI applications. If you go inside apps, you can find multiple applications. Today, I am going to demonstrate how to build a simple yet powerful AI chatbot using MongoDB's vector search capabilities, Olama models for generating responses, and Streamlit for creating the user interface. All this in local system using Docker Compose. I am using this local bot sample app from GenAI Showcase repository. But I did some changes to the code. We will go through that next. So if you see here app.py, then compose.yaml, then requirements.txt, then the Docker file. These are the libraries used by the application: Streamlit, Olama, LangChain, LangChain Olama, PyMongo, LangChain MongoDB, LangChain Community, and Markdownify. Streamlit for building the chatbot UI and handling interactions. Some of the components like st.chat input, chat message, st.write, and st.spinner we are using. Then Olama, this provides language models for generating conversational response in local system. We can use something like olama.pull for pulling the models. Then LangChain, this is the framework for building language model applications. We are using chat prompt template, str output parser, then runnable with message history, some of these classes. Then LangChain Olama, this integrates Olama models with LangChain, like chat Olama, then Olama embeddings. These are the classes we are using. Then LangChain MongoDB, this provides tools for storing embeddings and chat histories in MongoDB. The classes are MongoDB Atlas Vector Search, MongoDB Chat Message History. Then LangChain Community, this provides various utilities like data loaders and transformers. We are using something like web-based loader, Markdownify transformer, those classes. Then PyMongo, this for interacting with the MongoDB database. The functions like MongoDB client, list collection names, and others. This is the Docker file for the Streamlit app. So here we are using Python, then adding the requirements.txt, whatever we reviewed earlier. Then we are using pip install to install those dependencies. Then adding this app.py, that is the application file. Then we are running the server on port number 8501. This is the docker compose.yaml file. Here I did some adjustments to resolve the issues like loading Olama model. Here I just added Olama host http colon Olama colon the port number 11434. Also added these volumes to MongoDB to resolve key loading issue in my local system, also to persist the data. App.py, here also I did some changes to the original version to avoid dropping the collection and reloading the data every time the application is reloaded. This will help us to reduce the local testing time. Anyhow, in real case, the data loading pipeline is going to be separated from the chatbot. If you see here, we are using web-based loader to load content from 2 wiki pages and using embedding model, Olama embedding model to embed and store the data into MongoDB collection using MongoDB Atlas vector search class. This will create a DB with name bot and a collection with name data. Again, we are using the retriever to retrieve the matching documents from DB, also Olama model for chat. Here is the system prompt template, chat prompt template. If you go and find this system message, so this says you are a helpful assistant, answer all questions to the best of your ability. If you don't know the answer, let the user know to find help on the internet available context. Then we are defining the chain of operations. So one more thing, we are using MongoDB chat message history to store the session details or data. But anyway, we are using here common user, but we can extend this. So here again, we are using the database name as bot, but there will be a collection with the name message history will be created. Then we are using this history chain like runnable with message history to find the response. This is the chatbot. I already accessed this application. So the data is loaded. Let us quickly review that. Let me go to MongoDB client. So if you see here, there is bot, this is the database. Then there is a collection called data. So this has all the data and the embeddings. If you see your embedding. Now one more collection, message underscore store. This is empty right now because I did not send any chat input. Let me quickly try some of the chat messages. These are some of the example, but you can try with different messages. Also the data consists of details about AT&T also. So even you can chat with AT&T data. Let me go with this one first. This may take some time because we are running in local system. Okay, now we started receiving the response. Okay, so we received the summary on when was Bank of America founded. So all these details were available on the website. You can post more chat messages to the chatbot. The history of the chat also maintained as we discussed earlier. Let me quickly go to the database. If you see here, message underscore store collection was created. If I go there, you can see the chat history. It's a type human, then the session ID, but right now it's hard coded saying user. You can extend that. But otherwise, if you see the history, type human. So what was the data, right? This was the prompt. Then if you see here, again, type AI, the data, the response. So all the chat histories are maintained and displayed on the chatbot. Now I asked a question that is outside the embedded content. For example, what is Adobe Experience Manager? It says, I couldn't find any information on Adobe Experience Manager, so it cannot provide the detail, but still it can give some suggestion like you go and search it in internet or check Adobe's website and all those details. Okay, that's how you build an AI powered chatbot using MongoDB, Olama, and Streamlit. But this is just one use case. The MongoDB GenAI showcase offers many more applications you can build and customize. Check out the repository and give it a try. That's all for today. Thanks all for watching the video. If you enjoyed this video, please like and share it. See you all in the next video.